Hello and welcome to this video that we have promised to share with everyone. I'm sorry I may not be able to, not I may, I will not be able to show my face in this video because of the technicalities involved. So I would ensure that this video is very explanatory and easy to follow. So this is the lecture material or the manual that I shared in the WhatsApp group, and this is the training material that we used for day 2 Power BI or advanced data analytics with Power BI. Okay, so let's just rush through what we have already done during the workshop. We have looked at Power BI ecosystem, where I briefly explained the difference between the components, Power BI components, which include Power BI desktop, Power BI service, Power BI mobile, although I didn't mention Power BI embedded and Power BI report server. But the embedded allows you to use some custom applications via REST API, to integrate analytics into the web and apps, portals, etc. While Power BI server is an on-premise report hosting for organizations that cannot use cloud. Then I have introduced the Power BI desktop interface, and on the Power BI view, or open the window, we have these various views: the report view, the table view, and the model view. And I did explain what these various views are and how we use them. We'll see more of those views in this video. All right, so let me just go into where we stopped. We also did connecting your database to Power BI desktop, and we've looked at all of those. So I've introduced Power Query Editor to us, and we have performed some little transformations that's on the dataset we are working on. All right. Now I would like to talk about, I think we've done all of this already up to this point. Okay, we have done all these, and we've already also completed the lab 2.1. These are all the steps we've taken above. The last exercise I left us with is the challenge to write an mQuery function called normalize port, but we didn't write the function because of the limited time we had. So we created this new column called, what did you call the column again? Service name. We created a new column called service name, and then we assigned all the destination port 80 to the service HTTP, destination port 443 to the service HTTPS, and so on. All right, so this, although we didn't, like I said, we did not create the function, but we just did this using the conditional column option. Okay, now in this video, I'll start by explaining data modeling, but before I do that, let me quickly head on to my Power BI desktop, and I have already saved the file in this folder called cybersecurity lab that's found in my folder called SQL files. I saved it inside datafied files in the documents folder. So all I need to do, if you have saved your file from the last time we met during the workshop, just come to the location where the file is saved, double click to open the file. So you do not have to go open Power BI from scratch. Just simply come over here, double click on the saved file and get it opened. If for any reason you have lost your file and all the steps we've taken previously, maybe you've lost those steps, please let me know via the WhatsApp group. I would quickly do a short video to show us how to get to those steps that we've done. But right now, I just want to keep this short. Of course, it cannot be short because the steps that are remaining are still very much. So I want to try as much as I can to reduce the length of processes that we'll have in this video. Okay, so the file is up, and this is the data set we worked with, the network flows. When you scroll down, you find other columns that we added to these network flows, because I think I remembered, yes, this is a RiskTier and so on and so forth. So those were the columns we engineered, and I have already applied the steps and saved. So the last day I saved this was on the 28th, and I saved this 7:18 p.m. Okay, next I would like to show us the table view. Remember I spoke about these views, various types of views, the report view, table view, model view, and so on. But I said in this training we'll focus on these three views over here. If I want to see the sample, or just say a preview of my data sets that have been imported, right here on the data pane, we can only see the column titles and not the data set. So if you want to see a preview of the data set, you come to the table view, and from the table view, when you come over to the table view, it's going to show blank like this. All right, so for you to see it, sometimes you have to click here, especially if you have multiple tables. You may not see any data here, or if the table you want to see preview is not well selected, you have to come to the table view, or table data pane, I mean to say, and select it. So these are the columns that are presented right here. We have the destination port, the flow duration, the total forward packets, and so on and so forth. To see the columns that we added, I'm going to scroll from the scroll bar to the rightmost end, and then we can find those columns that we added. We added the column RiskTier, flow category, TCP underscored flag profile. We also added the column RiskScore. Okay, I think I have not created my own column on, let's go back to the instruction material. I've not created my own column on this, right? This very column called the service name. So I'll do that right away. And to do that, I'll get back to the Power Query editor. From the Home tab, click on Data Transformation or Transform Data. Once you do this, this brings you back into the Power Query editor, where the column will be created using the conditional column option. While this is loading, I like to go back to my document to see the instruction. So I would follow this whole was it all right. So this whole different numbers that are assigned to different service name. So we are back here now. Power BI is saying this preview may be up to 6 days old. I can refresh if I want. Click on refresh just to refresh the data set that is connected to Power BI desktop. Sometimes this refresh might take some time, so I wouldn't have refreshed because my data set is very large. But I'll just be patient for this to load. Once it is done refreshing, we would go ahead and add column, and then add by conditional column. And now don't forget that there are several ways, like I said, you can do this. From the instruction given here, we're meant to do it by defining a function, but because of the complexity that is involved in defining functions, I do not want to use that method. Now in maybe future training or workshop, or those who would decide to opt into a data fight training program, you'll learn how to do that by creating functions. Okay, so right now let's go ahead and enter a new column I want to create. So the goal or the objective, or what the step I'll be taking right now, I want to create a new function called service name. All right, or a new column, I mean to say, called service name. I'll be using conditional column. I'll click on conditional column under add column tab or menu. Once I do that, the add conditional column dialog box will pop up. The first tab that appears here is for me to give a name to my column. So I want to call it service name. Then on what column do we want to add these conditions? It has to be on destination port, because this numbers 80 4432221 and so forth. These are the various destination ports we have. So I'll click on destination port under the column name equals this. When destination port equals 80, I'd like to call this HTTP. So type it as is, HTTP. Then add clause. The next option is when my destination port is what number? 443. I'll call that HTTPS 443. We call this HTTPS, and add another clause. When my destination port is 22, I call that SSH. When destination port is 22, I call that SSH. Okay. Now, when my destination port is 21, of course, whatever you see here is still the same thing that is applicable to these numbers, but here all of it are not displayed. I'll use this option given here. So when my destination port is 21, I call that FTP. Add clause when destination port is 21, we want to call that let's call that FTP. Then we go back here when destination port is 23, I like to call that telnet. Add clause when destination port, if destination port is 23, let's call it what is it called again? Telnet, not telnet, telnet. Okay, then we add a new clause again. If destination port is 25, let's call it SMTP. If this is 25, we call it SMTP. Then we add another clause. Destination port is 53 DNS. If destination port is 53, we call that DNS. All right, and we add the next one, 3389. If destination port is 3389, we call this RDP. And we, for other destination ports that are not captured here, we want that to be referred to or considered as others or other. Okay, so this is a way to add your conditional calling. All right, we did this during the workshop, and this is another way. This is me doing it again, just to remind you of how to do this. So let's click on OK, and once that is done, Power BI Desktop is going to automatically add the column for you. Here's a column called service name, and the data type is not selected appropriately. So I'll change this data type here to text because it's actually a text data type. All right, I hope this makes sense. And once that is done, satisfied with what you have, okay, we can get back to our data modeling and star schemas. Now, in data modeling, like I said earlier, I think I should just read the short note I wrote here. Why data modeling matters. A data model refers or defines how tables relate to one another inside Power BI Desktop or Power BI. A well-designed model makes DAX measures simpler to write, visualizations faster to render, and reports easier to maintain. A poorly designed model, particularly one that focuses or forces Power BI to handle a many-to-many relationship or bi-directional filters unnecessarily, causes inaccurate calculations, focusing or confusing results, and poor performance. The gold standard for analytics data modeling is the star schema. So let me quickly do a kind of a quick search of what we mean by the star schema. We have the star schema and the snowflake. Okay, I've done what's it called, comparison of what the star schema and the snowflake schema looks like. But however, I like us to just do a quick Google search of what these two schemas look like, so that from there you can go back to that difference and then understand the star and the snowflake schemas. Yeah, the star and the snowflake schema. So let's see this. We're going to look at the image angle, image part of it and all. So this is the AI excuse me, the AI results for what a star and snowflake schemas are. Let's do a quick read here. Now it says the star and snowflake schemas are data modeling techniques for data warehouses that organize data into central fact tables or metrics and surrounding dimension tables or context. Star schemas use denormalized dimensions for faster, simple queries, while Snowflake schemas normalize dimensions into hierarchies or hierarchies. Yes, saving storage but requiring more complex joins. Let's see the pictorial representations of these schemas. Here we have the star schema. It's called star because you have one table and then as a fact table with multiple dimension tables surrounding the fact table, creating like a star-like shape. While in this case, for the snowflake schema, you find that you have, I think I love this. Okay, yeah, this is also an example of a star schema. Wait, for a snowflake schema, good. This here is a perfect example of a snowflake schema that relates to the description. There's a fact table, there's a dimension table. There are two tables connected to the dimension table, and then we do have another dimension. Then there's a dimension connected to another one. So this is snowflake. It kind of forms a snowflake, shape, and that's why it's called a snowflake schema. But the star schema forms a star shape. So these two schemas are the two types of schemas that you can create when building your dashboard in Power BI desktop. And I have already highlighted the differences between the star and the snowflake schema in terms of structure, in terms of query performance, complexity, redundancy, best for, and recommendations. So I'd like you to take a time to go over all of these differences between the star and the snowflake schema. Now I have a rule of thumb here that says always design a star schema in Power BI. Flatten snowflake dimensions using Power Query merge operations before loading. Power BI's VertiPark engine is optimized for star schemas. It comprises or compresses flat dimension columns extremely efficiently. Very important to take note of this point. So whenever you're building your dashboard in Power BI desktop, it is always advisable to aim at having a star schema in your modeling. Now let's focus on building the security analytics star schema from our data set. Now it's important we go through this point and understand what we're about to do before we implement the process. For the network flows dataset, will build a star schema with one fact table and three dimension tables. This requires splitting network flows into purpose-built tables using Power Query reference or reference queries. Now, pay attention to this. When we say the fact table is a table that has all numeric, values. Whenever you are dealing with a data set that contains some different dimensions or categories or context and some columns containing figures. Now, whenever you have a table that has only the figures and maybe connected or excuse me, only the figures and some foreign keys. Yeah, a foreign key is a column that is a primary key on a dimension table that is being brought into the fact table for the purpose of connection or relationship. So the fact table always contain those foreign keys and numeric columns. Okay, let's just go ahead and talk about how to the different dimensions we would love to see in our own analysis based on the security analysis we are trying to build. So we would have these following tables. The fact tables or the fact network flows table would contain, this is going to be the fact table, and it will have one row per network flow. It's going to contain the following columns: the flow ID, which is going to serve as the primary key, the label key, that is a foreign key. So label key is a key that comes from a dimension which we're going to see very shortly, and is going to be serving as a foreign key on this table. Then the port key, which is serve as a foreign key, and all numeric flow metrics will all appear here. Then we're going to create a dimension called attack label with the name dime underscore attack label, and that is going to be a dimension table, or that will be a dimension table, one row per unique label. All right, so this is going to have all distinct labels we have in our dataset, and it will contain the following columns: label key, which is serve as a primary key, the label RiskTier, the attack category, and a new column called is malicious. Okay, very soon we'll see how to create the column is malicious. Then we would have another table called dime ports, which will be a dimension table that contains the dimension port. We will have the following keys or columns: the port key, which will serve as a primary key, destination port, service name, port category, and finally we'll be creating a fourth table for the flow category dimension, and it will capture all flow category with the following columns: flow category key, which is serve as a primary key, the flow category itself, and the description. Now, I'd like you to note that the primary key is any column that uniquely identify each entry on a table. So all of these columns are assigned primary keys. When you check them, they would uniquely identify the entry, which means if a particular row has a primary key 5 as an example, no other row should have 5 because the primary key column must always uniquely identify each row. Okay, now that we have described and we've seen the various columns that we would have in our network flows data, it's high time for us to start creating those dimensions. So we can create dimensions using different methods. Can create by just going to Power Query Editor and then do all of these. Okay, follow the steps to create them. But I like it to be very practical as possible. So I'll do a step-by-step way of creating them by just taking out some columns or creating new columns that we need, and so on and so forth. The first column or the first dimension we'll be creating is called the attack label dimension. Let me head on back to Power BI desktop and get this done right there. Okay, we've implemented this or we've created this new column, so I'll need to go back to my home menu, close and apply to get back to Power BI desktop. Now, if this video is too fast for you, of course, you can always pause or rewind, get back to it, and ensure that you are able to follow through with the whole processes involved in building this dashboard. So at the end of the day, you will have a very insightful dashboard that can be used to track the network flows and every malicious activities that's happening on the internet. And we hope to have another training or workshop where we'll be building machine learning models that could identify or point out any kind of malicious move or any suspicious kind of attack on the website when building when going through a website. So let's just give some time for this guy to load before we continue. Let's give some time for it to load before we continue. If this part of the video is taking too long from your end, of course, feel free to fast forward it to a point where you can just go ahead and start off with the next part of the video. So our data has completely loaded into Power BI desktop, and we can find the column that we've just added right here. Let's get here. So here is the service name. So I believe you already have your column added, service name. Okay, now back to our goal. We want to create the attack label this dimension right here. So I'll highlight this just to copy the name because I want to label it exactly this way. And we said this column or this dimension should have the following column: label key PK, or which is the primary key, the label itself, RiskTier, attack category, and is malicious. Let's check out the instruction on how to go about this. So we want to use this particular way. Step 1, we are going to keep all label and RiskTier columns. Keep only label and the RiskTier columns. All right, let's do that right away. So I will make back to Power Query Editor, or what have I done? Back to the home menu, and to do that we need to go back to Power Query Editor. So I came back to the report view, click on transform data, So while in transform data, we would make a copy of the original network flows. Right click on this, then click on reference or duplicate. So for now, I would like to click on duplicate, okay, to duplicate this network flows data. The network flows data has been duplicated. I would go ahead and paste the name I copied, dime_attack label. Once that is done, remember we said we want to leave two columns right here. The what? We are leaving the label and the RiskTier columns. Only just two, the label and the RiskTier columns. So back to Power Query Editor. I will scroll to the end of this table. So let's do this. So the RiskTier and the label. Click. Okay, let me check again what columns we have here. We will need the RiskTier label and is malicious. All right, so I'm going to leave just those two, label and RiskTier. Okay, but before I do that, I would actually love to have fewer steps. So here is a goal. When building your data model or creating various dimensions from the actual flat file you have, it is always advisable to keep your apply steps as short or as few as possible. All these apply steps are needed for the network flows because whenever your data is updated, they'll go through these whole steps. But in my attack dimension or attack label dimension, I do not need the steps that we applied to arrive at these following columns: the flow category, TCP flag profile, risk score, and service name. So I'll take them out one after the other. I'll take out the change data type. I'll take out the added column for the service name. I'll take out the change data type for the risk score. I'll take out the added column for the risk score. I'll also take out the change data type for the TCP flag profile, the added column for that TCP, the change type for the flow category, and I'll take this one out for the, now we have the label and RiskTier. I have reduced the number of applied steps drastically. So I'm going to highlight, click on the label, hold on the shift key and select the other one to select the two columns of interest. Now these two columns of interest are selected. The next step is to right click on any of them, then say remove other columns. Not remove columns, remove other columns, which means the two that were selected will be left here and others will be taken out. And that's just exactly what happened. We've taken out the two other columns and we have the label and the RiskTier columns only here. Then the next step is for us to remove duplicates. Okay, so we're going to remove duplicates from the previous step that we have taken. All right, and now how do we remove duplicates? Now we want to remove duplicates on this label because all the labels that appeared here, they are actually duplicated. We just want the 15 distinct labels. So right click on the label column, then click on remove duplicates. Once that is done, the whole duplicates will be taken out and we'll have from 3.5 million plus data set, we just reduced to 15. You can see it now. We only have 15 rows. Do you see that? The next step, once duplicates are removed, we want to add a new label key column, a new column called label key. So I've copied this, and the label key is going to be a column that is added from index starting from 1. Back here, I'll go back to my add column tab, then click on index column, the drop down arrow and select from one. So this is going to serve as our the primary key for this. So this is it here. It's called index. Just double click on this column title. Once you double click, it will allow this column title to be selected. Paste the title label key, and I would always want my primary key to be at the front or the leftmost part of my table. And this means that whenever you see benign, it is assigned the primary key or the ID rather 1. Bot is assigned the ID 2. DDoS is assigned ID 3. DOS golden eye is assigned ID 4, and so on and so forth. That's exactly what it means. All right. And with this, we have successfully created our dimension for attack label. Okay, we have just one more column to be created right here. So how do we create this column? Say add is malicious flag. So let me copy this is malicious. And how do we do that? For add the column, so when it is benign, it is false, otherwise it is true. So I'm going to use a conditional column to do that. Click on conditional column and say call the name of the column is malicious. So if label equals benign, if label equals benign, okay, let's equals benign, let's say false. All right, that's the instruction. If label equals benign, let's call it false. Otherwise, let's call it true. So otherwise, else, let's call it true. So it means that we have 14 trues and 1 false. You can see it here, 14 true and 1 false, because other labels apart from benign are malicious, while benign is not malicious. Now it's giving me ABC 1 to 3. What do I want to change my data type to? True, false. All right, my data type here is true, false, because it has just only two outputs, true, false. Now with this, we have successfully created our attack label dimension table. Woo, congratulations to you if you're able to do this together with me correctly. Well done. It means you're making very good progress. All right, the next step is for us to create another column called attack category, right? Is that oh, wait, we are not done. We need one more column called attack category, not a table. So once we're done with this, we will move on to the next one, attack category. So what's the condition for attack category? It's going to be a conditional column also. Now we would like to say whenever it is benign, then it's the normal traffic. When it is labeled as DOS, then it's denial of service, DDoS, distributed DOS, and so on and so forth. Let's get back to this table. For our attack category, let's use the conditional column option again. Okay, let's give it a title, attack category. Now if the label, okay, equals benign, the label equals benign, we are going to call that normal traffic. So when the label is benign, it's considered as normal traffic. Then we add another clause. This time around, if it contains DOS, let's call it denial of service. That's what the DOS stands for, denial of service. If the label contains, not equal to, contains DOS, then that should be categorized as denial of service. Then we add another clause. This time around, it is distributed DOS. Okay, if the label contains DDoS, then let's give that category, let's call that category distributed DOS. We add another clause. The next clause is for web application attack. Okay, I'm going to highlight and copy this, web application attack. So whenever the label contains web attack, if label contains web attack, then let's consider that to be web application attack. Also, if label contains patator, we are going to consider that as brute force. Okay, so if add clause, if label contains the word not brute force but the word patator, let's paste this here, then we should give an output brute force. If the label contains or the label is equal to port scan, if the label is equal to port scan, then we should return reconnaissance. Add label if the label is equal to port scan, then we should return reconnaissance. Okay, if label equal to bot, we should return botnet. If label, add a new clause, if label equal to bot, then we should return botnet. Then else, let's return other. But these are the various attack categories that we want in our dataset as given. With this, we have now successfully completed our attack label dimension. Let me change this to text and we are good to go. All right, so because this video is becoming so long, I'm going to stop it here and we'll create the second dimension in another video, the other part of the video, and the third dimension and the fourth, and so on and so forth. So whenever you are done making changes in your Power Query editor, do not forget to always close and apply, and then you save. All right, but because the data set is large, let me just click on close and apply. It might take another couple of minutes to apply the steps that we've just done because of the kind of volume of the data set, or you have to be very patient. So I would oh great, this worked, did this application, it applied quickly because I've applied the first step already. Now to see your dimensions, come to this table view. You can find the uh, attack label dimension we've just created, beautifully positioned here, and network flows, which contains all the other columns. It is fantastic. And for now, I would like to save this work and continue in the second part of the video. To save your work, once you come to Power BI desktop, just hit on the save button since you've saved before, and now it's going to show you the date and the time the work was saved. Currently it's showing last saved the 28th of March, but once this is updated, it will show you the date this work was last saved. All right, thank you very much for watching this. We will continue again in the second part of this video, and I hope this has been very insightful and you've been learning a lot from the workshop that was organized. So you can see saved today at 10:44 p.m. So at least this will tell you when this video is being shot. All right, thank you and see you the next one. Goodbye.